The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. This is Mike Cass from Biamp, and today we're going to get together and talk a little bit about Vocia, a product line from Biamp that we're very proud to have. It's an opportunity for us to use a single platform to page. And in the world of paging, there's a couple different buckets we're going to discuss. Today's goal is to take a strict approach to paging and not get too in the weeds. This is the whole intent of this is to give a brief overview about Vocia and to give a brief overview about what we should be thinking about when we think about paging. So I hope everybody is staying healthy and doing well. I appreciate your attendance today, and we'll get started here in just a second. We've muted all mics to the end, so if you have questions throughout the webinar, please just put them in the questions tab. We'll take care of the questions at the very end. And so the way we're going to handle that again is just post your question, and one of our teammates will kind of sift through those and make sure there aren't duplicates, and then they'll pose the questions to me, and then I'll do my best to answer. So we're going to go ahead and get started. So Vocia, what is it? Vocia in our terms is just an excellent way to produce audio and background music to multiple areas of any kind of facility. And the difference that you're going to see with Vocia is just the scalability and the flexibility within this particular system and platform. It's second to none from a scalability and a flexibility standpoint as far as where does it fit. And we'll go over some verticals that it fits in very nicely and some different buckets as it relates to some buzzwords like emergency communications and mass notification and just simple paging or zone paging. So you're going to get to see the horsepower and the flexibility and scalability of this product line. That's one of our goals today, is that everybody walks away understanding that this is a single platform that can cover all those bases. So a couple of things that we need to know right out of the gate is that Vocia is a network-based system. And so what that means is that all of our pieces and parts that are connected, whether they are a input device, an output device, or anything in between, they're going to have a category cable, category 5 or above grade cable that is going to connect. A couple different reasons. That's how we transport the information to and from. Is through category cable. And then the second reason is a lot of our devices require the power to be from power over Ethernet through the switch itself. So we're using that network-based topology to not only take care of control, but the audio pathing and anything that we may need to do from a control standpoint from other systems to ours or vice versa. And so you can imagine that in part, that's where we get the scalability of the system itself, is because that infrastructure is based on the same infrastructure that a lot of systems or a lot of businesses are based on, right? For our computer systems or the systems that we work on, computers that we work on in an office environment, same type topology. We're going to follow that same idea that we're going to have a fiber backbone and we're going to have copper or UTP on the horizontal. So we follow that same topology. So when we talk about Vocia, we like to look at Vocia as a few different categories. We look at Vocia as we have input devices, we have control devices, we have processors, and we have outputs. Very, very common example is shown for each one of those areas. Inputs, we're going to have some type of way that we can make a page. Control, we're going to be using either a third-party controller or one of our controllers to control things like background music and source. We have processors that allow us to take care of any kind of loading, any kind of hierarchy where we maybe have user rights, or we have something above and beyond the ask of just a simple input or output where we need a little more horsepower. We have a processor that allows us to do that. And then a common use for an output is just an amplifier. There's more to it than that, and we won't take too deep of a dive, but just think about a common use for outputs as being an amplifier, because that's pretty common regardless of the manufacturer. So now we're going to talk about some Vocia specific terms, and one of them is a universe. And this is just a coined term for us and how we think about Vocia. And then the second one is a world. So the universe is as high as you're going to get. And in that universe could be a bunch of worlds, and it shows here up to 50, tongue in cheek a little bit there. That's a pretty big system if you get there. I don't think we have ever reached 50 worlds in a universe. What is a good reason to have multiple worlds? Well, if you have different buildings, if you have different functionality within the same building, you may want to create literally two completely separate systems but be under one platform. And so what that would mean in our terms is that you would set up the software where you would look at it, it was just as if it was two completely different worlds within a universe. And so that's why we do that. And then paging zones is something that we put a little bit of spin on. So a zone for us is a physical location where there is some kind of amplitude, some kind of speaker at the end or speakers at the end, and that's a zone. And what we're going to learn today is that there's a big difference between page codes and page zones. And what we will also learn is that within that topology, any kind of page zone or page code can be within one world or multiple worlds, as it lists here, up to 50 within that single universe. So when you think about, okay, I have a couple buildings here physically disconnected, and when you use that term universe from Vocia, you're really looking at it that these two buildings would become one. Perhaps it's owned by the same entity and they need to do paging at both buildings. Well, in our terms, that would be a universe because it's the same company or the same use case for both buildings, and that would be a Vocia universe. Worlds within that universe could be my example where, yes, they're owned by the same entity, but the day-to-day functionality is really different, completely different perhaps. And so that would be a good uplift to say, let's treat this like two completely different worlds. One building to the left has a day-to-day set of features that it needs, and it's quite opposite than the one building that's shown on the right. And so therefore we would create two worlds within Vocia software, and we would handle it just like that. The user's experience would be such that on the day-to-day, they would have very common feature sets that would allow them to quickly access to page just their building. And in the off chance that they needed to make pages to both, then they could do that, but that may be a little less common. So typical use cases is that, yeah, in the normal day-to-day, I just need to be able to make pages to my building, but there are times where I need to make pages to both. So I want that access. I want that capability at my fingertips. In that case, we would give that input device, let's say it's a paging station, we would give that paging station page codes, in this case, to both these worlds or both these buildings. So now let's talk about paging zones. Paging zones is literally, I could slice out a piece of the pie for my terms today, and that means that particular floor, it looks like the third floor of that building on the right, is a zone. And somebody could identify that, hey, that area needs to be handled separately or a little bit different. And so that zone literally would be physically wired differently. It would have a set of speakers, it would have a cable that ran back to one of our amplifiers, and we would identify that as a very unique zone. Its use case is going to be separate from the rest of that floor, the rest of that building, and in this diagram, both buildings, which we referred to as two different worlds perhaps. And so what we would do is every speaker, every amp channel would kind of have its own use case on a day-to-day, and that's how it would physically be wired, and that becomes a zone. So zones, we just improved and we said, okay, well, there were changes and the floor got bigger and the owner took over more of an area, and now that use case became bigger or wider, a wider spectrum. We need more. Well, what we would do is we would make sure that those areas, as I just added the fourth window there on that floor, those areas would physically have to be wired back. There's really no way to overcome that, except when we use multiple zones under one page code. So back here, if you look at our diagram, we only had 3 of these areas here that were actually a part of a zone. And then we'll just hypothetically say that there was some kind of advancement, some kind of need, where now all of a sudden it's 4 of these windows or areas. Well, if it was hardwired completely separate, it was back to its own amplification channel, what could be done is we would use a page code. And that page code then would incorporate both those zones. And that could be a fast way to make a simple software change and give us the flexibility to be able to now page into this new zone and have it act or function just like the previous slide, which showed just the 3 windows there of that single floor. And so you can start seeing the scalability that just from using a page code that we incorporate different zones, that gives us a lot of flexibility. Specifically, if there's going to be changes in the future, perhaps people move in or out or grow or go away in specific areas of a building, there may be different use cases. And then the last piece is that, this particular, hypothetically, this particular entity grew so large that they needed to take over the entire 3rd floor. Once again, anything that was connectorized, amp channel count or speakers, we could possibly take that in as just a page code, incorporate all those zones, all those amplification channels and speaker circuits, and now all of a sudden that whole floor, 3rd floor in this case, would act as one paging zone. So that's a little bit of terminology and the differential from some industry terminology and some specific terminology as Vocia sees it. So page code, we like to say that it defines the destination of the page. So in our scenario, we had 2 buildings, we had a total of 8 floors. Where do we want to page to? And if you tell us, well, I want to page to the 1st floor of building 1, then we're going to define that as a page code. And we're going to call it building 1, floor 1, and hypothetically again, and that's our page code. And that's exactly where it's going to page to. Keep in mind that, there's some other pieces and parts to that. We have to, functionally, we have to have an amplification channel and a set of speakers that follow that same idea. So there's a software piece and then there's a hardware piece. And as long as that's check, then it's very simple. We just define what the page code's going to be. And just as explained, it's going to be building 1 and it's going to be floor 1, and that's our first page code. So what's interesting is that as you start designing page codes, okay, you design a page code and it's 101 and it goes to zone 1. And you say, well, that's great, but in our building, we had those other floors too. So what if I want to combine all those? Well, with some systems, and back when paging first started, we combined all those together and we did what was called an all call or an all page. And that had its pluses and minuses, strengths and weaknesses. And so what we're offering is that it could be said that if you have physical wiring and you have amplification channels for zone 1, 2, 3, and 4 that are separate, the user could ask for all 4 of those zones to be zoned separately and have individual page codes. So what that means in our terminology is that we hypothetically could have a page code 101 for zone 1, 102 for zone 2, 103 for zone 3, 104 for zone 4, and then I'll throw another one in there, have page code 105, which incorporates, and we would select all 4 zones, and that's how we would get a all call in that scenario. So again, that scalability, flexibility, as long as the hardware set matches the design intent as far as software, then all that is at our fingertips. We literally pick that within the software to say, okay, what do you want page code 101 to incorporate? Which zones? So here's an example where I have page code 102. And page code 102 also incorporates zone 1, but perhaps it's a different zone 1. Maybe it's the zone 1 of this other world. And so the takeaway from this is that you create a page code. And so if we just learned that a page code can incorporate multiple zones or a single zone, it's really up to the user or the need case. Then basically what we can do is we can create all these different page codes to allow us to handle these zones separately or all together. So what happens when you have a page code or a user that's trying to reach all these zones at the same time? Something that Vocia does, and it can be programmed in very quickly and easily, it's a checkbox, is that what we do is store and forward. So I have one user who's paging, and they have page code 101 that's going to all 4 zones. I have a second user that's using a paging station, and they have page code 102, and it's going to all 4 of those zones, and it was already in use. First user who's using page code 101 that's covering the same zones already has the system in use. What will happen is that the system will store and then forward after those zones are available, not in use. There can be a situation where I don't want it to store and forward. It's very important to me because of the type of facility or because of my use case that I don't want those zones to even be available. So if it's urgent, if there's some kind of priority that takes place, if I went to use page code 102 and page code 102 excited those 4 zones that we showed in our previous slide, and it was already in use by an urgent or an emergent page code, then I would not be able to page into those zones. And that's what we call priority paging, whether it's urgent, emergent, or just a higher priority in general paging. So there's a way to kind of set up, hey, I do want some hierarchy. So let's flip the script. The user has credentials or page code 102 that's X'd out right now because it can't be used. Let's say that it had the higher priority and page code 101 was a lower priority. It was a very general priority. And I had something that was a little more urgent to be said. What would happen is that would give the user and the programmer the availability to trump page code 101 that was already in use, defeat it, and 102 could be heard. So how does it work and how does that all tie together? Let's talk about priority a little bit. So background music is common, and it's setting in the background, just playing music or some type of media, and it's very general. It typically has the lowest priority, and we have some analog outputs over here to the right and some speakers that are connected to a couple of our devices. And all of a sudden we want to make a page to zones 3 and 8. Well, the analog outputs at the top there on the right-hand side are going to zone 3, and all the pages in zone 8 are going out our amplifier and our speakers that we're showing there at the bottom right. If you look, what happens is that there's going to be a priority override. General paging is always going to have a higher priority than background music. And so what's going to happen is the background music is going to duck, and zones 3 and 8 are going to take priority. The person using our paging station there on the left bottom is going to make their page. And then as they release that page, background music is the only thing online, and it's going to go back to normal source. So background music is playing. There are no pages. There's nothing else going on in the system with higher priority. So the users through both what we called zone 3 and zone 8 are going to be hearing background music now. So that's a little bit about how you can take zone style paging with priority, and you could start figuring out that there's all these variables that we could program in very quickly so that it's a good user experience with lots of flexibility. So here's what's interesting about Vocia, and we'll get into this a little bit later. What we're showing there is just some common hardware, and there's a computer now that's connected as well. we like to say that's a programmer's computer. What's interesting about Vocia that's a little bit different is that we don't have to have software running on a machine 24/7, 365, monitoring or logging or having any kind of computation. What happens with Vocia is that Vocia can start from a single input and a single output. And what happens is that if I'm just doing a general paging system, everything that I need to know page code wise and everything that I need to know zone wise, as we've reviewed, is stored at the edge. So in that scenario, the page codes that are within the system would be out here at the paging station itself. And once my program is written and done, and I send it to my devices that are on this little system right here, I don't need the laptop anymore. I don't need a computation device. And I don't need a server. I don't need a server that kind of sits in the middle and acts as a traffic cop or an organizer of all this data. Vocia is a decentralized system, so it allows me to store the information I need to do general pages at the edge. In this case, at our paging station and at our amplifier. And I don't need anything more. So that goes to what we talked about earlier about scalability and flexibility. You could literally start with a single paging station, a single 2-channel amplifier, and that could be your entire system. The programmer would take their laptop, they would program the system, they would make sure that the paging station and the amplifier had the information that they needed, and you would be doing live paging. Then the system could just grow from there. So there's an example right there. So we strip all that away and we say, yep, that's how simple it could be. You literally could start with a single paging station, a single output device, in this case, a small form factor amplifier, obviously add some speakers to that amplifier and you would have a paging system. So the one piece that we talked about earlier, is that local network piece. So definitely we have to have a local network. A couple of reasons. One, that's how we transfer all of our information, in this case, from the paging station to our amplifier. Number two, because that paging station is seeking PoE through that category cable. So that's how it comes to life. So yeah, there's the network piece, and we've discussed that. But literally, that's your system. So that local network would be that PoE switch that we showed in the slide before, and very low complexity, very scalable. So that's how we start. And you say, well, that's great, but that's probably not very common for very long. So what happens now, where we've expanded, we have other equipment that's still a part of that world or that local network. Well, simply put, we add the equipment that's applicable, and we make sure that the software follows suit. We push that program out to all these devices. And again, in this case, I still don't have a server. I still don't have a computer that's running all this information, because I'm going to continue to push all that information out to all these edge devices. And so this is what we're showing here is this is medium complexity, right? Lots of inputs, lots of outputs, lots of different types of paging stations, amplifiers. There's multiple devices. We're still in a single world topology on a single local area network. Pretty common. Well, but it grew. Now all of a sudden, there's 3 buildings or 3 areas or 3 different, we'll just say buildings, 3 different buildings that are all connected via fiber, and they all have different use cases. So in this case, this would be a good on-ramp to look at having multiple worlds. So we would have a building over here that has a use case, a building down here, and a building over here to the right. All 3 of them have a different use case. And so they may be 3 completely different worlds, even though they're joined by a common backbone of fiber and a common network. In this case, we're showing that this is a local area network and that they're all joined via fiber. So once again, if the connectivity is there and the backbone is there to support it, then we would make some small changes to the software. We would push the program out to all these devices, and it would be paging as normal. Again, no message server needed, because we're connected via the same backbone of fiber, and we're on a single local area network. So, you know, at this point in time, it's probably a good opportunity to talk about why Biamp and why Vocia. We hang our hat on this pretty commonly. We have a 5-year warranty on our products, and the second bullet point is probably one that we don't do a very good job of pushing. Some government entities ask for this. They literally want it documented from the manufacturer, but it's mean time between failure, and we keep track of that, and we have to publish that. And anybody that would like to see that or needs it for a project you're working on, let me know, and we can get that document to you. If you're working with a regional sales manager, if you have a contact within Biamp's family, I should say, not just Vocia specific, they'll know how to get their hands on it as well. Comprehensive training, I think we're second to none when it comes to training. Our training program is just, it's run and developed by some of the best in the world, and I've been through it before joining Biamp's team and after joining Biamp's team, and it's just second to none. Worldwide support, and we don't tongue-in-cheek that. We literally have worldwide support. We can offer 365 days, 24 hours, 7 days a week, just because where we are in the world and the time alignment. There's literally 1 day, and I think it's 1 hour a year where there's a lag, and we take a lot of pride in our worldwide support. This is a worldwide deployment. So we have to be cognizant of that. We have to realize that while some people are asleep, others are awake, and Vocia is all over the world. So it's very important to us. We are U.S. manufacturer. We're based out of Beaverton, Oregon. That comes into play. If you ever have the opportunity to visit our manufacturing facility, please do. It is amazing. I remember the first time that I went through it, and then through our upgrades, I recently had the opportunity to go through it again, and it was amazing. I love the process and procedure, and if you're that kind of guy or gal, you'll get a kick out of the visit. Because of where we're based and just how we operate, as far as what componentry we keep on hand for assemblies, common assemblies, how we do our reporting, as far as looking into the future and seeing what product we're going to need and when, and looking at those forecast reports. It allows us to stay ahead of long lead items, and then our location helps us to ship out quickly. And then the last one is just, there's no special engineering or customization required. If a person has rightfully went through the Vocia certification class, and let's just say that they're an end user, which we highly recommend end users go through the certification class as well. You're going to learn a lot, and you're going to be able to operate this system, and we love that. You don't have to be a seasoned industry vet as a programmer to be able to operate the system or make simple changes within the system. So within Biamp's portfolio, we kind of have our own Google, I'll call it, and it's called Cornerstone. And Cornerstone is just our implant of our knowledge base. So anything that is public, this is where you're going to go to find it. So if you just go to biamp.com, you go to the upper right-hand corner, you're going to see a hyperlink that's going to take you to Cornerstone. I encourage you guys to go to Cornerstone when you have time, after we're done here today, or in the near future while it's fresh in mind. And I encourage you to go through and look at some of the data that I'm going to share with you today, and some of the articles and tech notes and some of the white papers that are there, and some of the things that we're going to get into here in just a minute as far as our design guides and what have you. That's where I pulled them from. I pulled them from Cornerstone. So by all means, take a peek at it. Again, I cannot brag enough about how well this is put together. I typically have it open when I'm working on something, just so I can quickly, if I have a question, I can quickly go to it. If I need a refresh, if I need a particular data sheet that I haven't downloaded, it's just a fast way even for me to go get information. This is a design guide for a regional airport, and this is just a quick example. It's it's not 50,000, but it's not, you know, a 50,000 view or approach, 50,000 foot view or approach, I should say, and it's not in the weeds, but it gives a lot of information. And what this is going to do is this design guide is going to have a nice piece of white paper. It's probably going to have a use case. It's probably going to have some kind of job reference, and then some kind of file that's going to go along with it. And again, I pulled this right off of Cornerstone just to show you guys today. Here's one that you know, is a medical center. Here's some design guides, different type of common equipment that's used. I think when you get to the bottom of this in Cornerstone, when you look, it's going to give you a typical bill of material, what that might look like, and then a typical file from a programming standpoint of what the Vocia file would look like as a whole. And here's, you know, just another one, school campus. So I've just put a few in here as a reference. Here's one that's becoming very popular, which is, as you may or may not know, Biamp acquired Cambridge, and Cambridge is the industry leader when it comes to sound masking products. And something that's taken off very quickly is the ability to have a masking system and not have to put additional paging speakers in. So I just pulled this. This is a common design. We walk you through what that design looks like. You end up with a copy of the program. You see the bill of material. And I just pulled this off as a reference, just so you could see, you know, what it looks like. If you're a pictorial kind of person, then you're going to be able to decipher what the pieces and parts look like and what the layout looks like very quickly. And then there's also going to be a common bill of material for this example, and then a copy of the Vocia file that you could literally download and see what the file would look like from a paging setup standpoint. You know, we're talking about Vocia today, and we're trying to pop the hood on some common use case and some terminology that we use, and kind of clean that up and not get in the weeds a lot. I'd be remiss if I didn't talk about Biamp as a whole. Biamp as a whole is a lot more than just Vocia. And so whether you know what these name brands are or these what these product lines are within Biamp, it's another good way to just kind of peek at Cornerstone and take a look. If you don't know, it's worth a few minutes just to kind of peruse the site. If you do know, it's a very good way. If you want to look at a use case for a community speaker, you know, for doing general type paging, then there's going to be a hyperlink, and you're going to see use cases of white papers and so on that's going to quickly get you to you know, the navigation side sometimes can be cumbersome. This is a quick way to get to the information that you need. So now I'm just gonna open it up for questions. Again, the idea behind this was just to take a quick look at paging and use some coined buzzwords from the industry, talk a little bit about use case, talk a little bit about how Vocia may differentiate from some other paging systems that you've worked with or you're working with now, and just kind of make you think about the differences between us and some of the others, and how we differentiate ourselves from general paging to some of the other systems that may be out there, whether it be urgent, emergent, or otherwise. So I'll open it up now for questions if you have any, and we'll go from there.
Nice. So we had a few questions come in during the presentation. First one from David. Do you integrate with nurse call systems, i.e. Hillam, Navicare, Nurse Call, to, for example, maybe auto-announce something like Code Blue?
Yep, we do, and we like to say this: nurse calls topology is going to be a couple different transports. We work very well with TAP protocol. We work with contact closure with logic state. So technically, what that means, or those are technical terms, and if we have non-technical people or people who aren't accustomed to those terms, this is basically what I'm saying. There's a protocol, a transport protocol or a language that most of the major manufacturers out there use, and that's TAP. And so we work very well with the major manufacturers to take that tap string, and then we have our own text-to-speech engine that deciphers that message, and then we use our text-to-speech engine so that we can relay all the codes, whether it's code blue, black, pink, and so on and so forth. And then the other way is just simple contact closure. Sometimes that's all we need, right? We want to push a button and we want a pre-recorded message to be played in certain areas. So yes, the short answer is very much so. That is one of our strongest verticals because now all of a sudden you are getting general paging and urgent paging all in the same equipment.
Great. Maybe kind of a related question. Is there an option for interfacing with VoIP systems?
Yes, that's a good question. So it's interesting because we do have a server. We didn't go into it and take a deep dive. And one of the use cases for having a server is for pre-recorded messaging. So if we have pre-recorded messaging, we're going to use one of our servers. Another great use case for our server is that it can act as a SIP device. So we don't get into it a lot in general type overviews like today, but good use case. You have two different worlds where you literally don't have fiber and interconnectivity. What we do is we put a server at each location, and each one of those locations is not connected by a fiber backbone. So we're in a wide area network topology. And so why do we do that? We do that because each one of our servers can act as a SIP server or SIP endpoint, and we can start a SIP to SIP session between our servers to just act as a gateway to page. So obviously there's some quality of service concerns, there's some latency issues. And so what happens is I'm paging from one MS, we call our message server an MS1E. I'm literally, I have a SIP to SIP session between those two servers. And what I'm doing is I'm saying, hey, I want to make a page to your building, but you need to take and buffer all this information or it's not going to sound right. It's the time alignment's going to be wrong. The information could be out of sequence, so on and so forth. So there's this buffering that needs to happen. So what happens is we call that store and forward. We're making a page from one building to another. We can't dictate what the lag is going to be from the wide area network. So it stores briefly on the second MS1E at the other building. Once all the information is compiled, it immediately releases it into the building, which is how we do what we call interworld paging. And that is SIP. So then we do have two other pieces of hardware that are very specific to this topic, which is a VoIP 1 device that allows us to basically cover the VoIP question. So it is a piece of hardware that has one of our cards. It is a 2-line or a 4-line up. So there's 2 cards or 4, excuse me, 2 cards or 1 card. And that 1 card has 2 lines. So you can have up to 4 lines dedicated just for VoIP traffic. And then there's a third device that we have that if for some reason we need to just use the copper backbone and our call manager, we do have a POTS style interface, which we call a POTS 1.
Does Vocia include scheduling?
Yes, and that's a good use case for the MS1E as well. So if you have certain events that you want to schedule a pre-recorded message at a specific time, somebody asked about a hospital topology where you have nurse call. So if you have a pre-canned message that needs to be, delivered on the hour, every hour, back in the day, that would be somebody getting on and making that announcement. Now we can schedule that release on the hour, every hour, which is, hey, this is a smoke-free facility. There are designated smoking areas, so on and so forth. Pretty common at a hospital these days. So yes, the answer is yes. And that scheduled event can do a lot of different things. The most common is to have a pre-recorded message, tone, something be delivered on some kind of schedule.
We'll do a couple more questions. I've seen a few come in. We will share the presentation and we'll share the recording from today and a follow-up email to anyone who's registered. So let's take one or two more. Can you talk briefly about potential tie-ins with visual paging either via digital signage or text message boards?
Yep, there's a lot of great manufacturers that do that, and we commonly are asked to work with them. It's a couple different. There's a lot of different ways for that design approach to go. So there's a lot of variables, but in general terms, we like to say that we can set in the middle. So you're going to have a lot of great manufacturers that specifically cater to that, whether it be digital signage of some way, shape, or form. And so they're going to have their form and function, and we may or may not be involved. If we are, we're the audio portion of that. How we get the information is going to be through control protocol. We have a control protocol called VTP, and it's our protocol. It's an open protocol. Any of the major control manufacturers have interfaced for years with it. It's a very simple protocol. We have a command string calculator, and basically if there's a need from one of the other systems to have Vocia do something, basically one of the on-ramps to make that happen is through our VTP, through our control protocol to make that. And that's a pretty common use case. But there's a lot of variables to that. And if there's a specific use case from the person asking the question, by all means, get with me and I'll do my best to answer your question. If there's a specific manufacturer or use case, I'll look at it and be able to help you decide whether it's easy or a little more complex. But the short answer is yes.
All right. There's a couple more questions, but maybe we'll take those offline. I'll get those to Mike, and you can get into more of the details of those specific use cases. But we did have some questions about the live in-person training. Like where does that usually take place? And do you plan to resume those maybe after COVID dies down?
Yeah, it's a very unique and very specific case where we have done live in-person training for Vocia, and it mainly has to do with today. I think the use case and the ask and the push has been to do more virtual. So we've certainly, you've noticed if you've done our training, you've noticed that a lot of our certifications, if not all, are online. And we have had folks that have said, hey, I miss that experience of going out to Beaverton and being at Biamp. I miss the training room. It is amazing if you've ever been. If you haven't, just take my word for it. It's an amazing opportunity to learn, and it's very well laid out and thought out, and it's a lab type experience. So you get your own hardware set, you get your own software. It's a good experience. And so it's not that we won't do them, it's that we've stopped offering that as a primary means of getting the information and, more importantly, the certification out. The second part is in person. In person with Vocia is a little tough because there's a lot of hardware. And so shipping that hardware to do in person, we just need to look at it. If it makes sense, the short answer is absolutely. Have we done it? Yes, we have done it. We have done in-person certification classes. And then from a training standpoint, in-person training, absolutely. So all of our regional sales managers and field sales engineers have their own demo gear. And we're geographically, there's a strategy to where we have our gear located so that if we need more than what that particular RSM or regional sales manager or field sales engineer has, then we can get our fingers on it very quickly to kind of cater to specialty one-off type demos or trainings. And so we can do that. It's just we need to know about it. So two different things. Demos, pretty easy to do, lots of hardware out there, lots of different opportunities. In-person certification classes, little bit more of an uplift, but can be done.
So if they're looking for the online training and certifications, where would they be able to find that?
You can go to Biamp.com, go to Vocia, and I believe it's one of the first hyperlinks. And what happens is wherever you are geographically, if you want to get certified, the regional sales manager in that area, that email request will come to them. They will authorize or go, hey, I'm not familiar with who's asking, so they'll reach out and they'll kind of field that call. And then from there, you'll get the approval. And once you get the approval, it'll take you to the portal, which is a self-paced type topology. So you'll be able to do it self-paced. If you have 5 minutes today and 2 hours tomorrow, then you'll be able to do that on your terms. And then you'll take a test at the end, and it's a pass-fail type test, and then you'll receive your digital certificate from there.
Great, thanks, Mike. I think we're gonna wrap it up and answer some of the questions that are left offline. Is there an email that people can reach you at if they have questions after the fact?
Yep, absolutely. And I'll add it to the slide if you're going to push that as well. Add that to the end here. But it's Mike.cast, which is C as in cat, A as in apple, S as in Sam, T as in Tom. So Mike.cast@biamp.com.
Cool. Great, perfect. So look for a follow-up email that will include these slides. So it'll have Mike's email on it and a recording from today's presentation. Thank you.
Thanks, guys.